training video. I'm Rob Garlick, and today we will be discussing movement of energy in HVAC systems. We will discuss the definition of energy in an HVAC system and ways to move energies with HVAC systems. First and foremost, we measure energy, heat loss or gain for HVAC systems in BTUs, or British thermal units. A BTU is a unit of heat required to raise 1 pound of water 1 degree Fahrenheit at an atmospheric pressure of 14.7 inches per square inch. For cooling, we use tons, which is 12,000 BTUs per hour. For heating, we measure it in either MBH, which is 1,000 BTUs per hour increments, or just BTUs. There are numerous ways to move energy in or out of the building. You have hot water, chilled water systems, direct expansion, VRF, gas heat, heat pumps, and many, many more. Your engineering group will determine the best system for the design. Several factors are used to determine which system is best to move heat in or out of your space. They use how big the space is, what's in the space, how it's broken up, location, things like that. DX cooling is often used in residential or light commercial buildings. That can either be a packaged rooftop or a split system like in a residential application. DX heating and cooling uses the refrigeration cycle to move heat in or out of the building. We'll devote a whole nother video to the mechanical refrigeration cycle. To cool a space with a DX cooling, the blower moves air across a coil. That heat is absorbed into the refrigerant, rejected outside, leaving cooler air given back to the space. It works the same way in a small packaged unit. Your return air comes up across the coil, the heat is moved to the refrigerant, expelled outside, and the cool air is provided back to the space. Heating, typically in residential applications, is either a heat pump, which uses the mechanical refrigeration cycle in reverse. You take heat from outside and move it to inside. Or you can use fossil fuels to burn natural gas or propane to add heat directly to the air. For larger buildings, we typically use chilled water and hot water systems, or VRF systems, which is a variable refrigerant flow system. It works very similar to the small systems in a residential application. Your return air is brought back across a heating or cooling coil. In this case, it would be a cooling coil. The warm air moves heat into the water. That warmer water is moved back to your chiller, where the heat is absorbed by the refrigeration cycle and rejected outside, and it moves cold water back to the air handler. That cooler, drier air is then pumped through the space. For heating in a large building, we typically use boilers when you have a chilled water, hot water system, and the coil works just the same. You add hot water to it, the air moving across it, that air absorbs the heat, moves it back to the space. There are several ways you can heat a building with hot water. You can use hot water coils in an air handler. You can use radiant flooring, which is piping in the floor which heats the concrete. You can use convection baseboard, which uses air movement across a small coil, or you can use radiators. There are many, many types of HVAC systems. We've only covered a few here today. We will devote more in the future. Remember that heat always moves from warmer to cooler. So on a nice summer day, the hot air from outside tries to come into your nice cool building, and in the wintertime, your nice warm air in your building tries to go outside where it's cold. So please always consult your engineering group with any questions. Thanks for viewing. See you next time.